Hello and welcome to this video on sequencers and the nth term. So during this video we're going to be looking at how to calculate the nth term for a sequence of numbers, and then we're going to be looking at how we might use that skill perhaps in some past paper questions. Now when you are being asked to calculate the nth term, what that actually means is you're just finding an expression. So you're finding an algebraic rule for a sequence of numbers. So I'll give you a really simple example. 2, 4, 6, 8, 10. That's your 2 times table. So that would be 2n for that one, a really simple example. So all of your times tables will essentially be that number followed by n. Okay, generally you probably won't get as one as simple as that in the exam, but that's just what it really is on a really simple level. The n represents the number you would like to find in the sequence. So if you wanted to find the 12th number in the 2 times table, you would do 2 times 12. And that would give you 24. Okay, if you want to do the 100th number, you do 2 times 100 to get 200. Okay, unfortunately, they're not as straightforward as that all the time. So your first question here, we've got this sequence here, and I would like you to work out the nth term for this sequence. So pause your video and have a go, and then I'll go through the answer just after that. Okay, so let's have a look at this then. Now, you will notice that the difference between each of the numbers in this sequence is 4. So if the difference is 4 and it is increasing by 4, that means the expression has got to start with 4n. So any linear sequence like this where there's a common difference of 4, if it's increasing by 4, will start with 4n. Then we've got to look at our first number. So our first number in the sequence is 15, and we've just got to take away 4 from that. So because now we're left with a positive number, we're left with 11. So 15 is 11 more than 4. What that means is the expression for this sequence will be 4n add 11. And if you want to do a little check for this, if we take that second number in the sequence and we do 4 times 2, that will get 8. Then we add on 11 to 8, and that will give us 19. So that's how you can check whether you've done it right or not. So I'll just write check there, so that's clear. And you can try it with the third one if you want. So 4 times 3 is 12. Add 11 gives you 23. Okay, let's do another example then. So we've got this sequence here. Again, have a go at the nth term for this one. Okay, so on this one, we have a common difference of 5 between those numbers there. So that means our expression is going to start with 5n. Then if we look at our first number, it's 3. So if we take 5 away from 3, we get minus 2. So what that means is our nth term is going to be 5n take away 2. Okay, because 3 is 2 less than 5. So all of the numbers in this sequence are essentially the 5 times table take away 2, essentially. So if you want to do a check, let's try it with the first number this time. Well, 5 times 1 is 5, and 5 take away 2 gives you 3. And let's try it with that fourth number, shall we, as well. So 5 times 4 is 20. So, and then 20, take away that 2, will give you the 18 there for your fourth term. Okay, let's do one more then. It's slightly more complicated, this next one. Okay, so we've got some numbers here then. So see if you can have a go at this one. Think about this one carefully. A little bit trickier, this one. Okay, let's have a look then. So this time we're going down by 8. So that means our nth term will be our first part of our expression, sorry, will be minus 8n. Okay, because we're going down by 8 each time. Then if we look at our first number, it's 90. If we do 90 minus 8, that will give us 98. Okay, because remember, when you subtract a negative number, it becomes a plus. So now all we've got to do is just write that on the end of our expression. So it will be minus A10 add 98, or alternatively, we can write this way. We can write 98 minus A10. Okay, so either one of those would be accepted as a valid answer. Okay, let's move on then. I mean, those questions were actually all from AQA papers that we've already looked at, but we're going to look at some ones where they're a little bit more complicated, perhaps, which might get you thinking a little bit more. So here's one from a paper, I think it was a couple of years ago, this one now. So A is an arithmetic progression. Okay, it says here are the first four terms of this. So we've got these four numbers here. Remember, an arithmetic progression is an add or subtract. Then it says G is a geometric progression. Here are the first four terms of that. Remember, geometric is a multiplication. So then we've got this information in this box here. It says the nth term of A, this first sequence, is the 8th term of G. So this sequence at the bottom here. So we've got to work out the value of n, and this was a 4-mark question here, so this one will really get you thinking, this one. So why not pause your video, see if you can have a go first, and then we'll go through it together. Okay, first of all, let's work out the nth term of this sequence. So you'll notice the sequence at the top is going up by 3 each time. So it's got to be 3n. And then if we take that 3 away from 13, the first number in the sequence is 13, that will give us 10. So the nth term for that arithmetic sequence is 3n add 10. That would get us some marks in the bag already. Then if we look at this, now it's just doubling each time here. So if we keep going, our 5th term will be 32. Our 6th term will be 64. Then we're going to get 128. Then we're going to get 256. So that is the 8th term in our sequence, in our geometric sequence. So that would get us some more marks as well on this question. So now all we've got to do is just put these two together now, because it's telling you that that is equal to that. So we write 3n add 10, and that equals 256. So now all we've got to do is just solve this little equation that we've got here. We've created now an equation because we've got this equal sign in the middle. So that'll give us 3n, if we take that 10 away, which will be 246. Then if we do 246 divided by 3, I'm running out of space to write this, so 246 divided by 3, that would give us 82. So what you've now figured out is that the 82nd term in that sequence above the arithmetic progression would be 256. So that 82nd term. If you want to check that I'm not lying, you could just do 3 times 82, which is 246. Then you could add on that 10 there, and that would get you to 256. So this is kind of a bit of a mixture of nth term, solving equations, and understanding those key terms. So it's kind of mashing a load of topics together, this one, which is why it was quite near the end of the paper. It was quite a hard question. Okay, well, let's look at one final question then. Okay, we've got a pattern, and this is something they sometimes do in exams. So rather than just giving you numbers, they give you little patterns either with sticks or with blocks, lots of different things. So we want to do the nth term just for the number of black squares on this one. Okay, so pause your video and have a go. Okay, let's have a little look at this then. So if you look in pattern 1, we've got 4 boxes there. Then we've got 1, 2, 3, 4, 5, 6 in pattern 2. Then we've got 8 in pattern 3. So if you look, the difference between each number, between the number of black tiles in each little pattern is 2. So this means our sequence has got to start with 2n. If we look at our first one, our first pattern has 4 black squares. So if we take that 2 away from 4, we'll end up with 2. So it's a positive 2. So the nth term for our sequence would be 2n add 2. So if we check that with pattern 2, 2 times 2 is 4, and then 4 add that 2 gives you 6. And as you can see, we've got 6 squares there, 6 black squares in that one. And that is the end of this video then. So thanks very much for watching. Please hit subscribe, and there'll be loads more content coming your way to support you with your GCSE Maths Foundation syllabus. Thanks very much. Bye bye.